everyone. In the last video we have discussed about some of the major disadvantages of file system, that is data redundancy and inconsistency. The another one is difficulty in accessing the data. Today I am going to discuss the remaining problems with file system. Let's go to the another point which is facing with the file system, that is data isolation. What we mean by this data isolation? We know that software programs are the effects of different programmers where they use different files, and each file use different file structures, and obviously they store in different locations as well. Obviously the data are scattered in different files in file system. In such a case, isolating the real data that we required is a problem because files may be in different locations, and that's why data isolation is difficult with file system, which is very easy in database. That's why whenever any changes made in a place, all the associated plates gets updated automatically. At the same time, data can be isolated because all the data are in one database. So we can done easily in database but not in file systems. So we are done with the third point, and we'll move to the next point, that is integrative problems. What is meant by integrative problems? Suppose I want to enforce some constraints and conditions to my data which is actually stored in the file system. But here we face consistency constraints in file systems. Example, account balance should not be 0. If this is maintained in file system, definitely it is really difficult in file system. But in DBMS, when we enforce that conditions like account balance should not be 0, whenever any update or insert is carried out on a particular row, and if the condition is not satisfied, then that activity should not be permitted in databases. See how the powerful databases are. But all this cannot done in with file systems. Of course, we can easily enforce these constraints in code. So it's easy to add software code but not in files, and that's why we have seen just now. Think we have enforced some constraints and suddenly we want some new constraints. Again, this is also a problem in the file system. And we have one more biggest integrated problem with file system is the problem is compounded when constraints involve several data items from different files. Means imagine our data is carried in different files, and obviously it will store in different locations. In such a case, enforcing some constraints is not easy in integrity problems with file systems. So we have done with the integrative problems, and we'll move to the atomicity problems which faced with file systems. Atomicity problems. File systems are really suffering from atomicity problems. What we mean by this? It's really difficult to ensure atomicity in a conventional file processing system. What we mean by this? Don't worry, we'll discuss it now. See, any system, whether it is software system or hardware system, any system is subject to failure, isn't it? When a failure has happened, it is an expectation from the system to recover from the failure. Of course, backup will be really helpful into this. So obviously, restoration of data is very essential thing when a system encounters failure. Now, when we have a backup, we can easily restore the data. I am not talking about the problem of backup here. I am talking about atomicity problems. See, the example, when you will be able to understand. Let's say I am doing a fund transfer that gonna enforce a condition that this transaction should be atomic. Like it means that transaction should be fully complete or none. When we see an example, it will be easy to understand. See, let's assume I am gonna do fund transfer from A's account to B's account. So this is what the example that I was talking about. Let's assume before the transaction has started, A is having the balance of 1000 rupees and B is having the balance of 500 rupees. Let's assume the transfer operation is carried out from A's account. I mean transfer of 500 rupees from A's account to B's account. It means from A, I am withdrawing 500 rupees and the new balance for A will be 500 rupees. Because this 500 is debited from A's account and expected to be transferred in B's account. So at this stage, A is having balance of 500. Remember, the debit operation is completed, but still the credit operation is not completed. After debit is completed, let's assume the system has gone a failure. In that case, the value is actually debited and A is ended up with only 500 rupees. And if we note here, the value is not credited to B's account. B is ended up with only 500, means payment system is accepted, and if A is 500, B should be 1000. It means amount is debited from A's account and credited to B's account. That's perfect. Otherwise the money should not be debited from A's account, so that consistency is maintained. So this is a real problem when we deal about a transaction, when we use files as a backend. So what condition I am enforcing is, if transaction is started, it should complete till the last. When the source account is debited, then the destination account should be credited. So I am enforcing a condition, if transaction has started, it should complete all, otherwise none. Say if failure has happened here, then the transaction should be revoked to the previous stage with A equal to 1000, B equal to 500. Even if there are some statements are executed, and if there is a failure, system should identify the failure and should revoke to the original place, like A should be the balance of 1000 rupees and B should be the balance of 500 rupees. So what we are achieving, all or none. So this is a main problem facing with the file system, and it is not happening when we use DBMS. So we are done with this, and we will go to the next problem, that is concurrent access anomalies. This is a concurrent access anomaly. See, this concurrency is good or bad. When multiple people work at the same time is always good. We know our databases store all the data in one place. Like let's assume if one person accessing the database, another person is referring from getting the access, because already one person is accessing the data. It's not good, right? Let's say we are accessing google.com. See, multiple people from multiple locations are accessing Google at the same time. So concurrency is always good, but there are some serious problems with concurrent access. That too, when they are accessing at the same time with the same data. Let's see that now. Concurrency is always good because multiple people can access the resource at the same time, but it may lead to inconsistency, which we need to address. So these are the problems when they occur with the file systems, and these are not happened in when we use DBMS. So this is a problem we are getting in with the file system, and we'll go to the next point, that is security problems. And security problems, we know the security is the important for anything, and we know databases or file systems are going to deal with the data. Think about the data is confidential, so obviously not everyone is permitted to access the data. So we are required to restrict the data access. So what I mean to say in simple terms is, we have to provide authentication and authorization. Authentication in a sense means all about identifying that the right person is accessing the data or not. Like we are using passwords, biometric, face recognition, fingerprints, and all these are authentication mechanisms. And the financial personnel should not access academic records. Enforcing access constraints in file systems is difficult. So security problem is the main problem. Security is the main problem with the file system, which doesn't happen in DBMS. So this is why we told that we need DBMS, because so we have discussed a lot of the problems faced with file systems. So all these problems can be overcome by using DBMS. So this is the reason we need DBMS, that is database management system. Hope you understand why we need DBMS. Thank you.